So if you have your 9.5 part 2, we're going to talk about coordinate conversion. All right, you get coordinate points on a coordinate XY grid, or we get coordinate points on a polar coordinate where it's our r comma theta. But do you guys, look at this. Everybody just look for a second. We're going to talk about stuff we already know. These two things right here represent the same point. It's just in different planes. A coordinate plane versus your normal XY grid. Our rectangular, right? This is our rectangular. And this is our polar. Remember, our theta is the angle. R is the directed distance. So if we're going to graph that, you find the angle that you're talking about. And then you look at your distance from the pole in the middle. If it's a positive distance, you go towards the angle. If it's a negative, you go away from. Correct? We talked about that. X and Y, you guys know how to do that. You go left and right. Now, does this triangle look similar to you guys? Yes, this is a right triangle, correct? And again, we talked about this the other day. Your origin on the XY and your pole in the coordinate, polar coordinate are the same thing. Your x-axis in your rectangular XY grid and the polar axis on the polar coordinate grid is the same thing. Does everybody see that? Now, back to trig stuff that we did. If we were trying to find r squared, would you guys agree with me we would take x squared plus y squared and we'd get r squared? Yes or no? Yes. So can I further say that r is the square root of x squared plus y squared? Right? Yeah, okay, we already know that. No big deal. So now we're going to talk about some stuff that I hope you remember. If I said to you, given an ordered pair, given an XY, it was on the unit circle or not on the unit circle, whatever. If I wanted to know the sine of an angle, given an ordered pair, what is sine? It is opposite over hypotenuse. Very good. What's another way we could name that using letters? Y over R. Perfect. Good. Very good. All right. What's another thing that we know? We know cosine. What is cosine going to give us? What's the relationship? X over R. Great. And then what's tangent? Y over X. All right. Good. We remember that. Yay. All right. So now we're going to kind of bring the two coordinate systems together. We're going to bridge polar coordinates with rectangular. If I was going to solve this top formula for y, what would you do to both sides to get y by itself? You'd multiply by r. So you'd have y equals r times the sine of theta, correct? Yeah. Okay. So what about if I was trying to get x by itself? What would it be? X equals r times the cosine of theta. Questions? We okay? Do you guys see a relationship? I know you have never in the past, probably. When we started trig functions, and you guys are like, oh, why did we go from degrees to radians? Why do we go from x's and y's to like our r measurement and stuff like that? There is a distinct correlation between your rectangular and your polar coordinate system. They are together. They are united. That you can go from one to the other. What we're going to do today is we're going to convert from polar coordinates to rectangular and then from rectangular to polar. And I'm going to show you how to do that. This next slide, you guys did awesome. This is exactly what we've learned before. This is chapter 4. You guys remembered it, so fantastic. What we're going to do today is use this down here. We're going to go from polar to rectangular. We're going to go from rectangular to polar, and you guys are going to be perfectly fine in this, I promise. When you are going from polar rectangular, you will be given the r value, and you're given the theta value. How did I know that? Because when you write a polar coordinate, it's r comma theta, right? So they're going to give you the r, the hypotenuse, if you will, and they're going to give you the angle that we're referencing. When you have a rectangular and you go to the polar, you can find the r value by using this, correct? And we're going to use the unit circle to find angle measures. Because they're going to give you the x value and the y. Well, tangent is going to be our y over x. So you can use these two numbers in here, and then you can use the unit circle to find the tangents at that point. Everybody with me? All right, we're going to do a couple examples, and you're going to say, oh my gosh, this is so easy. If I said to you right now, okay, guys, go ahead and convert. You're going to convert the point 2 pi from polar to rectangular. And you guys are like, what, huh? All right, so let's think about this for a second. This is polar. If we're starting off in polar, they're giving me the r, and they're giving me the theta, correct? All right, so just a second ago, we took sine of theta equals y over r. We rewrote the formula. We rewrote the formula to say y equals r times the sine of theta, correct? We rewrote the formula to say x equals r times the cosine of theta. Everybody with me? Yes or no? Okay, so if we're going to find the y value here, you want to find the y value first, x value first. It doesn't matter. Just make sure you write the x as the first part of the ordered pair, the y is the second. I'm just showing you can do it both ways. What is the r value in both situations? 2. Okay, so 2 and 2. Perfect. Now, how do I find this part? Well, think about it. Where is pi? What's the ordered pair at pi? -1, 0, correct? You guys agree with me? Okay, so I have -1, 0. Which one of these values is the sine and which one is the cosine? 0 is sine. Good. Remember that. Good. So high. And what is cosine? Guys, you just plug it in. So I'm going to say 2 times. Well, what is the sine? 0. And then here I'm going to say 2 times. What is the cosine? -1. So in this case, guys, your ordered pair for x is what? What's 2 times -1? -2. For y, it's what? 0. And there you go. All right, we're going to do a couple of these. All right, we're going to convert the point. Letter B says convert the point from √3, pi over 6. So I know that my r value is √3. And I know that my theta is pi over 6. So I'm going to write my two formulas. If you want to write x first, if it makes you feel better because your point is xy, that's fine. So I have y and x. So x is r times the cosine of theta, and y is r times the sine of theta. So what you're going to do is you're going to take the r value that is given to you, and then you find the cosine, and you find the sine. So what is the r value in both cases here? Square root of 3. It's always going to be the first number. It's always going to be the same. So then I have, okay, well, what are the values here? What angle did they tell me to look at? Pi over 6. Let's go to my unit circle. Where is pi over 6? So my ordered pair is the square root of 3 over 2, 1/2, correct? Remind yourself, which is cosine, which is sine? What's √3 over 2? It's the cosine, good. And 1/2 is the sine. So let's just throw it in our formula. I wrote x first this time, so I'm going to say square root of 3 times, what's the x value? Square root of 3 over 2. So then on the bottom, I have the square root of 3 times the y value, which is 1/2. So as we simplified, you guys agree with me, this is the square root of 3 over 1. So when you multiply across, what's the square root of 3 times the square root of 3? 3 over 1 times 2 is 2. Perfect. Now my y is the square root of 3 times 1/2, which equals square root of 3 over what? 2. There you go. That's it. Anybody have any questions? We're okay? All right, a couple more examples. Convert the point 4 pi over 2. So remind yourself, we're starting off in polar. So I have my r value is 4. And my theta that I'm going to look at is pi over 2. So go ahead and get your equation set up if you want to. You can write x first. X is r times the cosine of theta. And y is r times the sine of theta. In each case, again, guys, what is the r value? 4. Good. Now, pi over 2. Well, what's the ordered pair at pi over 2? 0, 1. It's 0, 1. I know you guys know this, but it might be helpful, just so you don't make a silly mistake, to say, okay, this is my cosine and this is my sine, right? So I'm going to say 4 times 0 and 4 times 1, correct? So what's my ordered pair? 0, 4. Good. Anybody have any questions? Let's do one more like this, and we'll go the other way. All right, label what you got. They gave you the R value and theta. So I'm going to write my formulas. I'm going to say, okay, well, x equals R times the cosine of theta, and y equals R times the sine of theta. In both cases, guys, what is your R value? 2. Perfect. So I have 2 here, and I got 2 here. Now, what do I need to do? I got to figure out what ordered pair we're talking about. Where is pi over 6? What's the ordered pair at pi over 6? Root 3 over 2 and 1/2. Okay, so I'm going to write it right here. Root 3 over 2 and 1/2. This is my cosine. This is my sine. Now, let's just fill it in. So, R times cosine. So, R times root 3 over 2. And then I have R times the sine, so 1/2. And then algebraically, what does this become? Well, this is 2 over 1. So what's 2 root 3 divided by 2? What happens to your 2's here? They cancel out, so you have the square root of 3, comma. What's 2 times 1/2? 1. And there is your point. Questions? So when you go from polar to rectangular, you're given the R value, you're given the theta. So what you're going to do is all you did was rearrange the cosine theta equals formula and the sine equals formula. You just moved it around algebraically. You can do that. And then remember, cosine is the x part of the ordered pair, and sine is the y part of the ordered pair. Been good? All right, now we're going to go the other way. We're going to convert the point 2, 2 to polar coordinates, all right? So 2, 2, what did they give me when they tell me the point's at 2, 2 on a rectangular grid? They gave me an x and a y, not 2 x's. Come on, x and a y. All right, so that's a good bit of information. Every single time, guys, find the R first. You need the R value and you need the theta. You need what we're talking about. How do you find the R? R equals what? Yep, x squared plus y squared. Perfect. So I have the square root of 4 plus 4. R is the square root of 8. Would we ever leave it as the square root of 8? No. What is R? 2 root 2? Perfect. Okay. So I know my point is going to be at 2 root 2 comma something. Well, what angle are we talking about? What angle are we talking about? Well, let's think about it. What did they give me when they said that this point was 2, 2? They told me that the tangent of theta equals 2 over 2. You guys agree? Put the y over the x. What is 2 over 2 simplify to? 1. This is going back to chapter 4, guys. Remember when in the first quadrant we figured out which ordered pair gave us a tangent of 1, which ordered pair gave us root 3 over 2, which one gave us root 3, right? What ordered pair on the unit circle would give me a tangent of 1? Pi over 4. Is there another one that would give me positive 1? 5 pi over 4, okay? Good, very good, Jeremy. When you take the y, put it over the x. There's only a few options that this could be. So I know that it's one of those two angles. How do I know which one we're talking about? Well, plot the point that they gave you. Where is 2, 2? Right 2, up 2. Where is this point? What quadrant? It's in the first quadrant. So which angle are they talking about? 45, but what is that in radians? Pi over 4. So your polar coordinate, when you have 2, 2 in a rectangular grid, your polar is 2 root 2, comma, pi over 4. You have to do a little more thinking when we go from rectangular to polar. We're going to do a couple of these. But again, what is the first thing you should find? R, all right? When you are given a point, you're given an x value and a y value. God bless you. You can easily find R because R equals the square roots of your x coordinate plus your y squared. So you have the square root of 1 plus 0 which is the square root of 1. Guys, don't leave it as the square root of 1. That's not simplified. What is the square root of 1? So r equals 1. Perfect. So then the second thing you're going to do is you're going to say, okay, well, my point's going to be at 1 comma something. What did they tell me? They told me that the tangent of this angle, the tangent of theta, is y, 0, over negative 1. Now, you could figure that out, say 0, but guys, where is the point negative 1, 0? It's at pi. So that's the angle that we're talking about. So your coordinate is negative 1 comma pi. I'm sorry. I don't know why I said it. I was looking at this. You're right. I'd already written the 1. It's just positive 1 pi. I don't know why I said negative. Well, I do know why I said it because I was looking at the point, but that's not what I meant to say. That's what I should have said. Questions? All right, let's do some more. Convert the point negative 1, 1 to polar. So right away I know, okay, this is my x, this is my y. So let's find r first. R equals the square root of negative 1 squared plus 1 squared. So negative 1 squared is 1, plus 1 squared is 1. So your r value is the square root of what? What's your r value? Square root of 2, okay? So now we're going to figure out, okay, well, what is the theta? What is the angle that we're referencing? So I have the square root of 2 comma. Well, they told me that the tangent of theta is y, 1 over negative 1. So where, guys, do we get the tangent of theta to be negative 1? 3 pi over 4, agreed. Where else? And 7 pi over 4. Right? Same point, same coordinates, I should say, same values, but opposite signs. That'll give us a negative. Now, how do you figure out which one they're talking about? Well, plot the point that they gave you. They gave me negative 1, 1. So negative 1, 1, where is it? What quadrant? It's in quadrant 2. So which angle are we talking about here? 3 pi over 4. Perfect. Good job. Does that make sense, guys? It's that awful. All right, let's do the last one. They gave me an x and a y. They're not beautiful, but that's okay. The first thing I'm going to do is find r. So I say r equals the square root of negative 1 squared plus the square root of 3 squared. Negative 1 squared is 1. What is the square root of 3 squared? Square root of 9, which is 3. So 1 plus 3 is 4. What is the square root of 4? 2. So your r value here is 2. Now to find your theta, the angle you're talking about. They told me that tangent of theta is the square root of 3 over negative 1. So now we're like, oh, which one of those points is it? Before you even start the math behind it, guessing and checking and all that, let's just talk through this. I need tangent to be negative square root of 3 over 1. So right away, what two quadrants can I cross off? If I want my tangent to be negative, if I'm going to take y and put it over x, I can cross off the first because everything in here is positive. And where else can I cross off? Y the third. Good, because everything's negative. When you divide two negatives, you're going to get a positive. Hold on. So now that we've narrowed that down, let's plot the point just so we have a visual of where this is. The point is negative 1 square root of 3. So if I go over left 1 and then up the square root of 3, I don't know exactly where that is, but I do know it's in what quadrant? It's in the second. So I can cross off here, correct? Is everybody with me? So now I know, okay, these are the only things that I can look at from here to here. So what I'm looking for is the negative square root of 3 over 1 as my tangent. Is the point at pi over 2 or pi in any way, shape, or form going to give me the square root of 3 over 1? 0, 1 or negative 1, 0. Is that ever going to somehow, if we combine it, get us negative root 3? No, so it's not here. What's another one we can absolutely cross off? 3 pi over 4. Why? What's that going to give me? Just -1. All right, so the only two options we have left, we have not had to do any math yet. The only two options we have left are 2 pi over 3 or 5 pi over 6. So now you mathematically, if you don't know which one it is, mathematically you got to work it out. I'm just going to try 2 pi over 3. I'm going to take the y value, square root of 3 over 2, and put it over the x value of -1/2. What do we do when we divide fractions? You keep, change, and then flip, correct? So when I simplify this, when I multiply, what happens to your 2's? They cancel. I'm left with the square root of 3 over 1. Is that what we were looking for? Yes? So then this is the angle we're talking about. So this point is 2 comma 2 pi over 3. The most math that you're going to have to do when I shouldn't say the most, the hardest computation that you're going to have to do is to figure out which ordered pair is going to give you the tangent that you are desiring, whether it be 1, 0, square root of 3 over 2, square root of 3, negative or positive, that sort of a thing. But other than that, guys, to go from polar to summarize, to go from polar to rectangular, what are the two formulas? X equals what? R times cosine of theta. And what is y? R times sine theta. All right, those two formulas. Because you're going to be given the r and the theta. So you use that information to go from polar to rectangular. If you are going from rectangular to polar, all right, find r first. Find r first because you have your x and your y. You're going to say r equals the square root of x squared plus y squared. And then the second thing you find is the tangent of theta, because you're going to have the x value, you're going to have the y value. So you put the y over the x, and then we're going to use our unit circle to help us figure out exactly what angle we're talking about. That make sense? Yes? Okay, all right.